welcome everybody to GeoHug. So before we do kick off today's session, I would like to take this time to acknowledge the traditional lands which are all coming from today. I live on the beautiful lands of the Gadigal of the people of the Aurora Nation, and I'd like to pay my respects to the elders past, present, and future. And yes, I am thrilled that we have Michel Nzikou joining us today. So Michel is a research fellow at the Centre of Exploration Targeting at the UWA and is a PhD graduate in exploration geophysics from Curtin University. And it is going to be absolutely brilliant learning from him today about developing QGIS plugins for 3D geological modelling. So this is going to be a fantastic session. I hope you all enjoy it. I will be promoting you up as panelists throughout the session. Please don't be shy. If you are able to get your cameras on or your mics on, you're more than welcome to come on through. Or if not, yes, please use the chat and we'll be opening up the floor at the end of the presentation. But yes, thank you so much, Michel, for joining. It's awesome having you here.
Thank you.
I was very curious before we get started, what got you into geology, geophysics, all the good mining stuff to begin with?
Well, I'm originally from the Congo, the Republic of Congo in Africa. For those of you who know the map very well, it's quite in the center of Africa.
Mm-hmm.
And one of the main economical asset we have is oil and gas. And I was aware of working in the oil and gas as a petrologist or petrophysics guy. So I end up doing science.
Yeah.
And once going to study, I realized that if you want to get into those fields, you have to look at earth science in general. So I've gone through all the cycle of studying in physics and end up doing my master's in Canada in geodynamics. Then I end up in Australia doing my PhD in exploration geophysics.
Yeah. So what have been some big highlights through your journey so far?
Well, the fact that you cross countries, it's quite a big changes, and culturally, I'm not the same person, I would say. And also in the exploration world, I've seen quite a good sightseeing, especially in the Pilbara when you have the sunset. Beautiful, as you can see it in images we saw everywhere on the news. So it's quite the traveling and also the experience looking at the rocks and different landscaping, especially when laying cable on the ground for things like MT surveys or IP surveys as well. So it's quite interesting.
Yeah, I love that. And I have been asking all of my guests to bring along their favorite pet rocks. So I'm really curious what you have for us today.
Well, I'm not a geologist, but because I love to have souvenirs, some of the exploration I've been, I managed to catch some which might look nothing for you as geologists, but this one here, I don't know which kind of sample it is, but it looks cool. And another one is this one. What I can notice, there might be a little bit of iron in this one, but I'm not sure. You tell me if you know. And this one, which quite shows you a little bit of different stratigraphic layers there. Yeah, that's what I've got so far. And I've been keeping them since 2019.
Wow. Does anyone know what those pet rocks were? Super keen to find out. Can you show the first one again?
The first one, it is this one, hopefully. The second one is this one. I don't know what it is myself. And the third one is this one here. I took it because of these layers. You can see how...
First one looks like opal.
Opal? Oh. Go. Few people think the second one is a breccia and the third one might be a turbidite layer. Well, there we go. That's very cool. Awesome. Well, thank you, so much, Michel, for joining. If you want to share your screen and we'll get stuck into your presentation. Thank you.
All right. Thank you for the opportunity, Jess, to be part of geohug series. Today, I will be talking about developing QGIS plugin for 3D geological modeling. And this work is led by Michel and myself. We both work at the University of Western Australia at the Center for Exploration Targeting. So a little bit of content. We talk about why do we do this, and then give you a little bit of overview of Loop 3D and the algorithm involved, then the platform, which is QGIS, why, and then I'll wrap up with showing different demos of the plugin for 3D modeling, structural modeling, and geophysical modeling, as well as some acquisition or tools that we have to kind of bring in the same place legacy data from your acquired data in the field, and then end up with the training we will be running next year. Of course, we need money to run this project, so thank you to all the sponsors. Well, this motivation comes from the project 6 of the automated 3D modeling. It's about the usability of Loop resources. This phase is very important, not only because the challenge in moving toward the socially greener future is high, but our ability to improve our subsurface is increasing with the technology. For example, to help mitigate risk associated with exploration, a fast and accurate 3D modeling of the Earth is needed. While there are greater algorithms developed by many researchers out there, these resources can in majority only be used by the research group or by experienced coders. Unfortunately, such great work end up only as publications. If a research project is designed to reach a social, economic, and environmental impact, I guess we could probably ask the question, how much of this could help reduce model uncertainty, for example? Some of the question might be how to increase the usability of our existing algorithm. One will think of open source packages. In this talk, we show that more user-friendly frameworks with less data manipulation are needed to help improve into these directions. So build 3D models in a fast and reliable way, use open source for better reach, package the existing algorithm in QGIS framework. So the overview of Loop project. Loop project consists of building an integrated 3D geological and geophysical modeling. By the way, Loop is now a foundation. It comprises of three main pillars. You can see green, reddish, and yellowish there. So you have one is the geological knowledge manager. This is where one of the algorithms sits called map to loop, which I will discuss later. And then over the reddish side, we have the geological and geophysical modeling. This is where you actually build all the engine for 3D modeling, both structural and geophysical. And then on the left-hand side, you have the uncertainty mapping and risk mitigation. On the uncertainty here, it is a case where we all know that all the models are wrong, but how do we build more models to mitigate the risk in our exploration? So building more models, estimating the uncertainty will help elevate all this risk for our assessment. So the first algorithm I'll be speaking is called map to loop. You have to think about it as a map deconstruction. So you have a 2D map. It is an open source, automated extraction of geological information from maps, unbiased, repeatable process. It is a 3D geological model input generators. Pick that word, input, model input generator from geological maps. It is a high-level implementation of codes that help reduce the challenge in reproducing input data for 3D modeling. This library combines automatically information available in digital maps with conceptual information, including assumption of fault and Plotton, for example. The latter being the expert field knowledge. Current usage of modeling software manually process the input data and then build one model on the fly. However, with this engine, it takes raw data such as geology maps to provide unbiased input for 3D geological modeling packages. It is a fully automated process Therefore, multiple tests can be studied, and it is open source. Anybody can access it and use it. So this is the output. On the right-hand side, we have a subset of what the output look like if you run map-to-loop. So on the left-hand side, you have 4 layers: geology, polygon, fault line, structure point, and the digital terrain model, which you need to run into this engine so that it produces this subset, for example. But we know from now that map-to-loop is similar to what machine learning or AI terminology called data augmentation pipeline. Because in AI, machine learning, they say, how will we augment data? So it's pretty much similar to the same concept, but this is not a black box. So shown here, with left screen, we have contact fault. If you can see it, contact fault, fault offset, fault mean offset, the fault unit thickness, fault strat offset, and down throw. This is just a subset of what you get from map-to-loop. And the second one is called the loop structural. By the way, map-to-loop, it's pretty much just like a processing workflow where you generate input needed for your 3D modeling. And the 3D modeling engine here is the loop structural. It is as well open source. It uses full field dataset, contact bedding, cleavage, fault offset, and unit time relationship. It is a 3D geological modeling library with a very flexible API for building geological model. Unlike existing solutions such as GeoCAD, GenPy, GeoModeler, this open source provides a platform which integrates more geological observations, type, and knowledge into modeling workflow, while it uses structural framework and user field data set. It built model based on the time relationship between the formation event. Here, I want to, what I mean is, it uses the age of structure to kind of build your models. So if you use this engine, on the left-hand side, we have a network graph stacked from younger to older event. This is one way of representing some of the output of your result from map-to-loop, which shows you exactly how things are correlated based on different time scale. That's the network graph. And then this is just a visualization of what I showed earlier, map-to-loop output. And then these are used to go through the engine to produce, for example, this loop structural output, this model. The platform QGIS. Why QGIS? QGIS is free and it's open, and it has a lot of extension, plugin, reliable and constantly updated. You can design your customized plugin, very simple and effective graphical user interface to work with, seamless to connect with database and export and import spatial data and form. So there's quite a lot of advantages to use QGIS because it's free and open. Once you install it, it became yours, and you can actually do a lot as you expect if you know a little bit of how to code. So to design this 3D modeling, what we did basically, we envisioned to have a front end where, because we know a lot of geologists are not good coders, so we're trying to let all the geoscientists doing 3D modeling not to struggle to go from data to 3D model. At least that process need to be streamlined in a way that you don't have a lot of work on your way. And we realize that with QGIS, we can build our front end. And here is the front end of Loop plugin. By the way, it will change in the next release because we're trying to put it in the doc. So what you have to do, you only have to have 4 different type of data: the geology polygon, the fault, the structure, and your digital terrain model. Then you can go from there. If you know how to use the plugin, then you can go from there to your model. And because a lot of 3D modeling calculation require a lot of computational power, what we need to have is to send the calculation on a server. It might be a personal machine if you have a very powerful machine, or on a server, big machine like let's say HPC or Azure or AWS, to send all these calculations both for map to loop and for loop structural. So the communication is basically you do the first pre-processing of the data, which is local to your machine. And then once you agree that the data that you pre-process is okay, one of the advantages is you can review those pre-processed data in QGIS before sending it to the engine. So if you are happy with the pre-processed data, then you send it through your server for the calculation. The first calculation will be map to loop, and map to loop, once you view your map to loop result, then if you're satisfied, you can send the result output to your server again for loop or structural. The way it works here, you have a server running on your remote machine. And in this test, the server is built under a Docker container where you have all the mechanism to communicate with a feedback loop. It will feed the data into the server. Once calculation done, the result is then transferred on your local PC. The result can be checked as well in QGIS. If not happy, non-realistic geological feature can be removed in the data. Then repeat the process until some level of satisfaction. So it's very easy to use and friendly, so you can see exactly, because there are things that may not make sense for you as a geologist, then you have this time to tweak or change some parameters when you pre-process the data. So the most of the time you probably will be doing is on the processing part. Once you get it right, then the other part will be just more or less like an automated framework. Okay, this is the first demo. Here we can see our major processing steps. The modeling is staged in 3 main parts. The first part is the data processing, which is basically this tab over there. This step crunch your map data, retrieve the most important data table, and recreate new data with a smaller size. Also, it creates a dictionary for the field name and algorithm values. As well as, if you require, you can run it on your local machine by letting it create a Python file for anyone who wants to run in their own machine locally. But this step, we kind of hide it because it requires you to have the environment set up on your local machine to run the calculation. The reason we don't want it to be activated, it's because it takes a lot of stress to kind of create an environment suitable for your processes. And the second step, you can see once the pre-processed data are created, both the run map to loop on the bottom here are activated and loop structural tab. Then for the second step, we push the data into map to loop engine, which will create the detailed data from the 2D map. This data can be used for multiple applications, for example, urban geology and so on. And the finally is the data pushed back to your PC. So you just run the calculation and then wait for the result. And then you can check it as well. However, this is very time consuming when you do the 3D modeling because of the multiple calculation it will generate. But with a decent size of data, for example, the one I'm showing in this module, it takes you about 1-2 minutes, the whole process. Then at the moment, we know that QGIS is lagging with embedded 3D visualization. So we're using different packages to kind of populate this visualization. But the result of this output are given to you as a VTK format. But we can create the result in a form, and this is the format you want as well. So because we are still in the testing phase, and also a lot of government or companies, private company have security issues, and so very difficult to have a common decision on which data format you will have to produce. So we are actually looking at more queries and see how people are operating on the site to see whether we can try to embed all these kind of data format to see for visualization. So what we did here is basically just loading the data. But what if you want to repeat the same exercise with the same data without loading it? Then we have released on the new version, a preload data JSON, which is not shown on this video. So basically, when you load your data, if you click, for example, on the geology layer, it will ask you, do you want to load it from a JSON file format, or you want to do the same thing as before? Then because you saved it once, then you have all these parameters saved in your directory as well. You can just retrieve all the information and change some of the small parameters. And because of what I've said earlier, that companies are having issues with securities and even getting QGIS on their computers and stuff like that. So we know that WSL, Windows subsystem of Linux, comes with all the Windows machines. So at least we are close for them to using this QGIS plugin because they already have it. The only thing they will probably need is to have the Docker container running on the machine, and then if they have QGIS, they can run it as well. The second QGIS demo that I will show you, this is called the Geological Maps. This QGIS plugin was developed by Elliot Bent, Mark Jessel, and Julian Perret at UW to support the QField template developed by Julian. Here, the plugin is being used to import and harmonize legacy structural data using a fuzzy text matching algorithm. We finally can interrogate the newly imported data using a StereoNet tool. To better manage this field data, Geological Maps is built using embedded processing tools in QGIS. Because of the challenge we have in getting data from various sources, such as our students, researchers, also from geological surveys, private companies, as well as other researchers, and everyone uses different systems, that we know. So this tool was developed to harmonize lithological and structural observation so that we can end up with a nice and unified system. This is the first stage to collect field data in an harmonized fashion. And you can see when it gets green, that means we fix it. When it's color coded, so you can tell that this doesn't match, and you have a combo box somewhere here, a delete function and delete function. As a geologist, you can tell this does not make sense, then you delete it. So it harmonizes things from the same spot that you've been working. And then it creates new layers for you as well at the end of your pre-processing. So it's quite a good tool to have, especially when you are collecting data, or if you want to do a first pass processing to see how much of data that exists in the area and then try to harmonize it in the same way. Another one is the SG tool. This QGIS plugin developed by Mark Jessel at UWA to support structural geophysics training course and allow the course participant to apply standard filtering to geophysical grids. So in this example, we import a grid format file and perform some simple processing steps. You do the reduction to a quarter, regional removal, the tilt angle, and the beta version of several filtering and grading algorithms are provided. In this stage, we provide field geologists with enough knowledge and tools for basic geophysical reprocessing using the principal filtering method. So it's all there. You need to do it, and then you can see. So when you do this, you can actually go back to doing your 3D modeling to see where the things matches as well. And the final one is the TomoFast. This QGIS plugin developed by Mark Jessel at UW to allow users to build the input field file needed to run TomoFast gravity mark inversion. TomoFast is the algorithm that you can do gravity and mark inversion jointly or separately as well. And in this example, we load a gravity data grid and define a model mesh, subsample the data, and define inversion parameters prior to launching the inversion on Windows subsystem Linux. Finally, we visualize the inverted density grid we're using ParaView. As I said earlier, we don't have a visualization tool within QGIS by now, but we are collaborating with a company working for 3D visualization within QGIS, and hopefully by the end of 2025, we hope to have the visualization embedded in the plugin as well. So to wrap up with upcoming training, Loop 3D Foundation and the Loop platform will organize a conference on 3D geological modeling to discuss current and future workflow. approaches and application, and unsolved challenges of 3D geological modeling at all scale. The conference will run in person over Tuesday 8 and Wednesday 9 April. A series of half-day workshop will be organized on Monday 7 and Thursday 10. So the scientific team is the 3D geological modeling method, integration with geophysical interpretation and modeling, application to resource management, water mineral telling, application to mineral exploration. So we'll be seeing things like how to do 3D modeling using physics-informed machine learning, for example, for structural modeling in this conference. So it's quite very interesting to be part of. And if you feel like you'll be joining us next year, the QR code is right on the screen here. Just take a photo and then you get all the information. This is basically all the links that if you want to access some of the things that I've shown here, you have Loop 3D, you have two algorithms and the QGIS plugin, and then the feed mapping tool, your geohug, and then some of the reading as well resources, and the geophysical processing tool. That's the GitHub repo, that's the QGIS plugin itself, and then the TomoFast, you have the reading material resources and the QGIS plugin. So plenty of material to go. And I think that's pretty much it for today. And I would say thank you and time for your question if you've got questions.
Thank you so much for that. That was awesome. I really appreciate you taking the time. I am curious if it's possible to, some people couldn't see the fonts very well in the demos.
Okay.
Are you able to open up the program and maybe run one quickly?
Yeah, I can
Would
go
that be
back.
okay?
Yeah.
Amazing.
Yeah, basically, this layer here, this is where you do the processing. On the left-hand side, you only need 4 layers, the DTM and the polygon, geology polygon, fault line, and the structure point. And then once you have the 4th input, then it will activate the processing tab for you to create the new data type. Not the new data type, basically recreate the new shapefile with only the information you selected. This is because usually when you want to send the data on the server, the heavier, the slower it might be during transfer. So we select only the column of the data that we need and then recreate new shapefile within those frame column. And then those are the data we will need to transfer to the server for calculations. So that's what it's doing. And one of the advantage of this is, as a geologist, you know, French servers, when they record their data, sometimes they may label it with French names. So what you're doing for the pre-processing is basically you're doing a field mapping. You generate, you pointing toward your data table, what is the formation row or columns that the algorithm should use for processing.
This has been wonderful. Thank you so much for getting involved. It's been awesome having you on GeoHug. So thank you for taking the time.